2006 Nissan Frontier, the P0420 trouble code. Some of you guys know what this is going to be. This is going to be a catalytic converter code. This car actually uses a three-way catalytic converter. There's only one catalytic converter on this car, even though it's a V6. So before I plug in my scan tool, let's go ahead and do a little analysis on this, see what could cause this problem, and see where to go next. P0420 code, a little more depth. So your car is a device called a catalytic converter. We'll go ahead and draw this out so you guys can see it better. For those of you who don't know what a catalytic converter is and what it does, is it's used to remove harmful emissions from your car's exhaust. So a catalytic converter is two sides. The side with exhaust coming in, exhaust in. The side with exhaust coming out, exhaust out. Burnt fuel has several different components, and that's going to be part of your exhaust in. These components are carbon, hydrogen, oxygen, and nitrogen. And the goal of the catalytic converter is to actually remove oxygen from this system. And the reason it does this is because these molecules, carbon, hydrogen, and nitrogen, can actually bond with oxygen to form harmful emissions, like carbon monoxide, COX, and NOx. And because we care about our environment and don't want this to happen, we put catalytic converters in our cars in order to produce cleaner burning exhaust emissions. So, how is the system regulated? Go ahead and get rid of some of the stuff so you guys can see what I'm about to draw better. It actually has two components called O2 sensors. You have an upstream O2 sensor, which comes before the catalytic converter, and a downstream O2 sensor, which comes after the catalytic converter. And basically what they do is they monitor the amount of oxygen, they monitor the ratio of oxygen to fuel in the exhaust and produce a signal that then tells the car's computer, one, whether or not the catalytic converter is working properly, and two, tells the car how much fuel to deliver to produce the correct air-to-fuel ratio in your car's exhaust. Let's look at the upstream O2 sensor first. So the upstream O2 sensor actually spits out something called a sine wave, and if you remember your trigonometry days, you'll recognize this. And this is actually output in voltage, specifically 0 volts to 1 volt, or lean condition, too little fuel, for 0 volts, and or a rich condition, too much fuel at 1 volt. Since the computer is constantly switching between too little fuel, lean, and too much fuel, rich, it averages out to about 0.5 volts on the signal, which produces a value called stoichiometric. What is stoichiometric? So, as I mentioned before, the computer has to produce a very precise fuel-to-air mixture in order for the car to run properly and get good gas mileage. And if that mixture is off, i.e. too lean, having too little fuel, or too rich, having too much fuel, the car won't run right and will produce too much emissions. So let's look at the downstream O2 sensor next. So the downstream O2 sensor, like the upstream O2 sensor, does measure oxygen, but it produces a curve that looks much different. It doesn't oscillate and constantly switch between 0 and 1 volt like the upstream O2 sensor does. Instead, it's fairly flatlined and it doesn't really get a whole lot of oscillation. And the reason it's like this is since the goal of a catalytic converter, as I mentioned before, is to remove oxygen from the exhaust. And since O2 sensors only detect oxygen, if the catalytic converter is doing its job, there actually shouldn't be any oxygen after the catalytic converter. And this is reflected by a flatline pattern in the downstream O2 sensor, which basically indicates no oxygen. But let's say our catalytic converter isn't working properly. Then our signal would look something like this. It would look very similar to the signal produced by the upstream O2 sensor. And this would tell us that there's actually oxygen coming through the catalytic converter and thereby producing harmful emissions in our exhaust. And that's not something we want. So I went ahead and plugged up my scan tool here. It's a little quieter inside the cabin. You should be able to hear me a little bit better. It's scanning for codes right now. So you should see that P0420 popping up shortly. So as I was saying before, this car has two O2 sensors. It has a upstream O2 sensor and a downstream O2 sensor. So what we're going to do is we're going to look at the readings from both of those O2 sensors to see if they're in line with our theory we just discussed. So let's look at this code. Yes, when I erase my previously stored data, let's read our codes. So P0420, as I mentioned. So let's go ahead and pull up our live data. We'll find those O2 sensors. Do a custom data set. O2 bank 1 sensor 1, bank 1 sensor 2, bank 2 sensor 1, and bank 2 sensor 2. This car actually has 4 O2 sensors since you have 2 exhaust manifolds because it's a V6, so it's 2 times 2, 4 O2 sensors. So let's go ahead and pull these up. Alright, so here's what we got. So looking at our bank 1 sensor 1 and our bank 2 sensor 1, that's going to be our upstream O2 sensors. Our bank 1 sensor 2, our bank 2 sensor 2 are going to be our downstream O2s. And basically what we want to do is we want to see if we can get an oscillating signal out of the second O2 sensor, since, as I mentioned before, the goal of the catalytic converter is to remove oxygen from the exhaust. And if it's not doing that, we should see a signal that's rapidly switching between rich and lean, 0 and 1 volt. So let's see if we can reproduce that by getting this car up to 2500 RPM. Not seeing anything yet. I'm going to hold there for a few seconds. See if I can get the switch. Something I forgot to mention, this car actually isn't warmed up yet, so if it's not warmed up yet, you're going to get erroneous readings. So let's give it a minute to warm up. So I'm going to hold it at 25 RPM, get it to warm up, see if we can get it to switch. Alright, so looking at our bank 1 sensor 2, I don't know if y'all saw that, I could see it switching a little bit. Yeah, our bank 1 sensor 2 is definitely switching. You can see it switching from 0.1 to 0.8. Let's keep an eye on it, see if we can get it to switch a little bit more. Yeah, it's definitely switching. I'm gonna call this a bad catalytic converter. So we'll go ahead and replace that and see what happens. What did we learn from this? So we looked at our upstream O2 sensor and our downstream O2 sensor on bank 1 and that frontier I just showed you guys. And we saw this pattern on our downstream, which isn't really something we wanted to see. If you remember from my other drawing, it should be flatlined. You shouldn't be seeing this constantly oscillating rich lane signal like you see on the upstream O2. So we called a bad catalytic converter. I'm going to be honest, I haven't replaced it yet, but when I do replace it, I should see this symptom go away. We should see a flat line, straight line signal, and that should fix the problem, but I'll keep you updated when that happens.